started. Just got to bookmark my weird questions page. There we go. Cool. Okay, so first things first is I want to review how to solve proportions, okay? Because we will be doing that with the probability. So what do you guys remember about how to solve these? How do we do it? Anybody remember the process? X over 8 equals 28 over 32. Anybody remember how we solved those?
Cross multiplying?
Yeah, very good. You got it. We are totally going to cross multiply. So what we do is whatever numbers are across from each other, that's what we're going to multiply. And then you just divide by what's left over. So 8 and 28, we're going to multiply that. So 8 times 28. What's 8 times 28, guys? What do you think? I have a calculator, but I'm lazy. I don't want to do it. So you do it, please. Oh, you guys are awesome. 224. Beautiful. Okay, and then we're just going to divide by what's left over. So what's 224 divided by 32? 7. Good job, you guys. Cool, and then let's do it on this next example here. So on this next example, guys, what would I multiply? What do you think? What would I multiply in this next example here? Yeah, very good, Mr. Sam. Good job. And Sarah, good job. We're going to multiply the numbers that are across from each other. So 76 times 15. What do I get when I multiply 76 times 15? Oh, beautiful. 1140. And then we're going to divide by what's left over. And oh, look, we're dividing by 10. So all we have to do is boop, cross off that 0. Very good. So that's 114. Cool. Do you guys remember doing that? Cross multiplying? All that good stuff? Look, I use springy colors. Yeah. Good. Good stuff. All right, so it is week 6. Today we are going to talk about probability and the coordinate plane. So pretty quick lesson. I'm not going to lie. It's not designed to take forever, at least. So this is what is due this week. You have 3 assignments due. So, and there are 5 days of class. So it's a perfect time to get caught up. Okay? So you have predicting probabilities, experimental probability, and then something on the coordinate plane, because we're going to talk about graphing. Woohoo! I love graphing. Love it. Okay, probability. We started a little bit last week, but you guys did not have live session last week. So, you know, for grins, we're just gonna get going. So, probability is the measure of how likely an event is to occur. Okay, so to find the probability or how likely an event is, we would make this little ratio here, okay? We would say the number of the event, so the number of times something happens over the total number of outcomes. And what would you guys expect a probability to look like if it's definitely going to happen, if it's absolutely certain? What do you guys think? If an event is definitely going to happen, what would it look like? It would be a 1. Yeah, Isabel, you're totally right. Anything that is certain is a 1. What about as a percentage? What would that be? Yeah, good job. 1 or 100%. That means it's certain to happen. Does anybody, what's an example of something that is certain in our life? What is 100% chance of something? Death? Yeah, you're right. There is 100% chance that someday you will pass on, definitely. Being born? Yep. There was 100% chance you were born and not hatched from an egg, because that doesn't happen with humans. Good. What else? That you will breathe. Yeah. There is 100% chance that you need to breathe. Very good. Good. Okay. What about something that is, what would we say? Like, equally likely to happen. So if something is certain, that's 100%. If it's equally likely to happen, or it has an even chance of happening, or people say about 50-50, you know, what kind of a probability is that? Yeah, 50%. It's if it's about, you know, an equally likely chance because it's equal that it could happen or not happen. Okay, that's what we would say is equally likely. It either could or it could not. What has an equally likely chance of happening in life? What has a 50-50 chance? That's a tougher example. You could say there is a 50% chance that you're hungry or not hungry, right? Meeting the love of your life, yeah. Yeah, that's a tougher one because it's something that either is or is not. So, like classic probability, I think of flipping a coin, you know, that would work. So what would a probability look like if there's no way of it can happen? There's just no way. It's never going to happen. What would that probability be? That would be 0. Yeah, either a 0 or a 0% chance. Yep, living forever. That is true. There's a 0% chance the sun won't rise. Growing wings. Yeah. Yeah, exactly. Good job, guys. It's kind of fun thinking about all that stuff, right? I love it. Okay. That is true of hating Harry Potter. I don't know. That might be a little subjective. People might disagree with you there, which, you know, I don't. I love Harry Potter, but I know. I agree with you. I totally do. Okay, so let's talk about these would be theoretical probabilities of rolling a die. Okay. So this dice, so we're going to talk about this one, has how many sides? That has 6 sides. Yeah. So when you're finding the probability of rolling a die, usually it's going to have 6 sides. And those 6 sides means that it has 6 outcomes. And when you are asked P of 4 like this, that is true, Sam. So maybe not a 0% chance of dying from a pebble, maybe like a point something percent chance. I'm not really sure. That would be a tough one to remember, to measure. It would. Yeah. So, okay. So to find the probability of rolling a 4, that's what it's asking for here. The probability of rolling a 4. Whatever is in parentheses, that's what they're looking for. Okay, so how many sides on the die have a 4? 1. Yeah, there's only one side. Yep, good job, guys. So there are 6 sides total. So the probability of rolling a 4 is 1 out of 6. Now, usually probability, they just want to know as a fraction, but how could I turn that into a percentage if I wanted? Could go to the best calculator ever, right? And what would I have to do to turn 1 over 6 into a decimal? Decimal first, then a percentage. How do you take 1/6 and make it a decimal? What do I type in? And it's good to review this because, you know, it's easy to forget. So how do you change a fraction into a decimal? What do you do? What do you guys think? That little fraction bar tells us to do an operation. What operation also uses a fraction bar? What do you guys think? Can you guys still hear me? Hello, hello. Oh, good. Okay. So if I wanted to turn this 1/6 into a fraction, all I have to do, and that's okay. If we don't know, that's all right. No problem. Is we're going to go 1 divided by 6. So we're just typing it into Desmos just like that. And that tells us the decimal. Does anybody know what would I multiply that decimal by to turn it into a percentage? Yeah, 100. You got it. Good job. So I would have a 16.7% chance of rolling a 4 on the dice. So if you're asked to give a percentage, you're just going to go to Desmos or a calculator and type in 1 divided by 6. That'll give you your decimal. And then you take that decimal and you multiply by 100. Oh, there was a 1 there. So it's 16.7% chance. But most often, probability is given as a fraction. Okay, because what that means is for every 6 rolls, you have a chance of one of them being a 4. Okay. Questions on that. So it's always what you're looking for over the total amount of outcomes. We're going to do a few more examples. Questions on that? Any questions? Please let me know you're there and alive and paying attention by saying yes or no. What do you think? Henry, you alive?
Yeah.
All right. Aiden says, Declan, what about you? Sarah? Kira? Oh, yeah, you are. Yeah, you are. Taylor, Aiden, Corey. Okay, good. Good. We're just checking in. Remember, ask questions, let teacher know. It's all good. Okay, let's think about this one now. Okay. So we have another 6-sided dice. Okay, we want to find the probability of it being even. So we got to think, how many sides on that 6-sided die? So we know there's 6 sides, so that's going to be my total outcomes. How many could be even? Ooh, Isabel says 1/2. I like it. He's very good. Okay, so Sam, good job listing the outcomes. Sam, we could get a 2, a 4, or a 6. So there are 3 different choices on that 6-sided die that are even. And then according to Isabel, we have to reduce this fraction to 1/2, which is right. So that means 1 out of every 2 rolls could potentially be even. And what percentage is that? What percentage is 1/2? 50%. So there's 50% chance that you're going to get an even. And think about this. This will blow your mind a little bit. Out of the 2 choices, even or odd, one of those choices is even. So it's the same as the die. It's interesting thinking about it. So there's a 1/2 chance. So you're always thinking how many fit what's in the parentheses, and the denominator is your total outcomes. So all the possibilities. So what about the probability that you don't roll a 2? Guys, what's my denominator going to be? What's my denominator going to be? If I take this dice and I want to find the probability of not rolling a 2, how many total outcomes? Yeah, there's 6. There's 6 total outcomes. And how many are not a 2? 5. There are 5 that are not a 2. Good. What about number 3 here? Probability of a 7. Okay, yeah, no, let's go back and ask questions. What part is confusing? Because I get it. We're kind of going a little speedy there. I get this. But whenever you think of these fractions, your numerator is always what you're looking for, which is what's in the parentheses. So the numerator, this is how many sides of the dice are not 2. That's what the numerator is. It's whatever the parentheses kind of tells you what it is. And the denominator is the total number of sides of this dice. So if I was doing number 3 here, okay, a dice has 6 total sides. So that doesn't change every single time because a dice always has 6. But now let's do what's in the parentheses. How many sides on the dice have a 7? How many sides on a 6-sided dice have a 7? 0. Yeah, Sarah, you were like, wait a minute. Yeah, there are none. There are no sides that have a 7. So this would be a 0 probability because it can never happen. Okay, so whenever you guys are finding probabilities, your denominator is the total number of outcomes, total number of options, and the numerator is whatever the parentheses tell you to put on there. Okay, let's do some more examples here. I got lots of examples here today. Okay, so let's look at this spinner. We want to find, okay, we have a spinner that has how many different sections on this spinner? 4. There are 4 sections, and they're all labeled different, okay? So according to this problem, I want to find the probability of spinning an A. Good, Isabel. Yeah, very good. So what we're going to do is we're going to make a fraction out of how many are A over the total number of sections. Okay, so how many of those sections are A? According to Isabel, there's 1. And I agree with that. There's just 1 A. And what is the number of total sections? How many sections are there total? 4. Very good. There are 4. So yes, we have a 1/4 chance of spinning an A, and Isabel is right. That is 25%. Very good. Now, what's cool about finding probability is that you can actually use it to make bigger predictions, okay? So 1 out of every 4 spins should give us an A, according to this, okay? Now we want to make a prediction. So this is how we make a prediction. And you definitely want to write this down because this will come up in your homework. So if I spin the spinner 400 times, how many times should the spinner land on A? So what I'm going to do, good guys, yeah, you're totally right. You're totally right. Now mathematically what we do is we're going to cross multiply, but you might not need to because you guys are very good at reasoning that out. Okay, so the chance of getting, yep, Aiden, you're so right. That's exactly the way to think about it. Good job. So 1 out of every 4 times gets you an A on this spinner. Now we want to figure out how many out of 400 times. Notice how when I set up my proportion, I have the total amount of times on the bottom, and the part for A is on the top. So guys, all we have to do is cross multiply. What would I cross multiply in this example here? If I did it this way, and not the way you guys reasoned it out, which is perfectly acceptable, but just asking about this way. What would I multiply here? Yeah, good. I would go 1 times 400, which gives us 400. And then I would divide by what number? Yeah, I would divide by 4. That gives me 100. Good. Very, very good. So I would expect 100 times to land on A. But you guys thought about it perfectly. You did a great job. Yeah, you might not need to do this every time, but it's good to know how. Who has a question on what we just kind of did? Any questions? It's okay to have questions. If you have a, yes, you're right. You're right, Sam, you're so right. Very, very good. Okay. All right, and if you come up with questions, let me know. I get it. Okay, so let's talk about experimental probability. Okay, so we have Heidi, And she actually did the experiment, okay? She flipped a coin 5 times. So experimental probability is a little different than theoretical probability. Theoretical probability goes off of how many outcomes in theory there should be, but experimental is what actually happened, okay? So when you come up with experimental probability, so the probability of something happen is always on the bottom, it's going to be the number of times you did the experiment. And then whatever you're looking for goes in the numerator. Okay, so Heidi flipped a coin 5 times. Where is that 5 going to go in my fraction for probability? Is it going to go on the top or the bottom? Bottom, yeah, that's the number of times, the denominator, that she did that experiment. She got HT, heads or tails for her results. What is her experimental probability of flipping a tail? So how many times in that experiment did she get tails? 2, yeah, there were 2 tails, 2 out of 5. Okay, now let's see, how does that compare with theoretical probability? How does that compare? So let's make that a decimal so we can actually compare them. What is 2 out of 5 as a decimal? So what is 2 divided by 5? You're thinking about it right, Isabel. You just forgot a decimal. That's all. What do you think? Yeah, Isabel, what you were doing is you were probably thinking of comparing it to 100. You were thinking as a percentage. Because we get 0.4, but if we made it a percentage, it would be 40%. Very good. Okay, so now let's think about the theoretical probability. We'll say 40%. Okay, when you think about flipping a coin, okay, theoretically, how many options do you have when you flip a coin? 2, you have heads or tails. And we want to find the probability of tails. So what would my numerator be? 1, that's right. And 1 out of 2 is 0.5% or, 0.5 or 50%. So Heidi's experiment didn't quite match. They're pretty close though. But yeah, interesting. How do you guys think, question for you guys, how do you think Heidi could potentially get her experimental probability closer to this theoretical probability? What could she do to get her results a little bit closer? How could she increase that percentage? So I'm Heidi, and I'm going to sit down and think about my experiment. And I'm going to say, darn it, I really wanted to get 50% of the chance of getting tails. And I only did my experiment 5 times. That's my hint. What could she do? Yeah, maybe not one more time. Maybe she could keep flipping it. Maybe she could do a lot more experiments, right? Yeah, no, you're right. The more that she does the experiment, the closer she's going to get to that theoretical probability. Okay, so she could change that about her experiment if she could do it more times. Very good. Good stuff, guys. Good stuff. Okay, cool. I want to talk about plotting points real quick. You got to review this because we're getting close. So you guys are going to be getting charts like this. Oh my. Hold on. I know. I love these too. I love it. We got to review how to plot points. Okay? Who remembers where the x-axis is? Where's the x-axis on this coordinate grid? Who can write it right on the screen for me? X-axis, excuse me. So I want to label. Good. Yeah, that is totally the x-axis. Very good. Good, we got that one. So let's label y-axis. Where's the y-axis? And remember, if you don't like type or writing, you can type on the screen. Yeah, that is the y-axis. Good job. Where is the origin? Good, very good. That is the origin. It is also known as what coordinate point? What is the origin known as? Yes, 0, 0. Good job. Okay, you know how we have the little stamp things? Who can put a arrow stamp in quadrant 1? Someone put the arrow stamp. So it's next to draw. There's these little stamp things. Yeah, that is quadrant 1. Good job. Someone put the heart in quadrant 2. That's not quadrant 2. You'd think so, but it's not. That is a different one. Yeah, that one is quadrant 2. Good. Logical guess though on the bottom. Quadrant 1. This is quadrant 2. Okay, someone put a star in quadrant 3. Yeah, very good. This is quadrant 3. And then someone put a X in quadrant 4. Yes, good. This is quadrant 4. Nice. Okay, so those are our different quadrants. And if I want to plot a point, okay, remember points are always X first and then Y. Okay, X first and then Y. So if I wanted to plot a point, I would start at the origin and then move according to the X and the Y. Now look at this chart here, guys. This is a very common way that you're going to see points listed for you to graph. Okay, what is the first point off of that graph? What is the first coordinate point? Yeah, very good, very good. We would say it is the point 1, 4. So I would start at the middle and I go over to 1 on the X and then up 4 on the Y. So this is 1, 4. And remember, this is positive X, positive Y, and then down here is negative X and negative Y. Okay, good. What would my next point be? Yep, that's 2, 6. Good. I go over 2, up 6. What about my next point? 3, 8. Good. And then what's the next one? 4, 10. Good job. And that will make a line. Cool. So we're going to get into graphing all that stuff. Quick question, friends. How would I graph negative points? So let's try -3, 4. Where would -3, 4 be? And remember, -3 is x, 4 is y. Yeah, good. Over 3, up 4. This is -3, 4. Good. What about -3, -4? Where's that one? Yeah, very good. It's starting at the origin. It's over 3 and then down 4. What about 3, -4? Very good. Over 3, down 4. Nice. Very good. Cool. So you're going to have to answer questions about how to graph, just points. Okay, so let's think about this. This is making our predictions, okay? If you rolled a dice 48 times, how many times would you predict not to roll a 6? So what we're going to do Sam, that's a good question. It's supposed to be for you guys, but I wrote it weird. So, okay. So first thing I want to do here is I want to find the theoretical probability of not rolling a 6. What do you guys think that probability would be? How many times are not 6 compared to the total amount of sides? What would that be? How many sides on a dice are not 6? Not 8, I would say. Oh, and you might, Sarah, you might be thinking about this thing. Don't worry about that for now. Before we can get to the 48, we first have to come up with our theoretical probability. No R, theoretical oh, that's okay, no problem. So theoretical probability, let's think, how many sides are there on a regular dice? How many sides? What do you guys think? Regular, normal dice, how many sides are there total? Yeah, there are 6, that's right. And how many of them are not 6? If there are 6 sides, how many are not? There are 5 that are not 6. Okay, so I have the total sides, and this is how many are not 6. Now we want to make a proportion with that 48. Where would I put that 48 in my proportion? The bottom, yep, because that's the total amount of times. And then we're just going to put an X up top. And if I cross multiply, that'll tell me how many times not to get a 6. So what would I multiply here? It could be. It could be. What would I multiply here? I wouldn't do 48 and 6 because look how it's set up here. 48 and 5. Yeah, I'm going to go 48 times 5. What's 48 times 5? Oh, that's okay. No problem. What's 48 times 5? 240. And then, yeah, we're going to divide by 6, by that number that's left over. So 240 divided by 6 No problem, Sam. I gotcha. It's the same as 24 by 6, which is 4, add a 0. 40. Very good. And you might have a different way you worked that, and that's okay. This is true, yeah. Oh, all right. Does anybody have any questions for me? Any stuff that we should work on? All right. Well, if you have no questions, that is all I have for you.